In continuing our study of the graphs of functions, looking at a picture of this equation via a table of values, please come to understand that a function can be described in the form of an equation, in the form of a table of values. Remember, it's often unlimited, and in the form of a graph. And that's kind of where we're headed here all the time. And then we're going to continue to discuss the topic of what is the domain and the range of any particular function. And our focus in this video is going to be on quadratic functions. Quadratic functions are those types of equations that have a squared term for the independent variable x, just for the independent variable x. So I would like to talk about graphing these. The shape of a quadratic function is always in the shape of a parabola. A parabola looks either like this with arrowheads on either end, or an upside down U with arrowheads on either end. So let's start with a pretty straightforward one, y equals x to the second power. So the independent variable, remember, is x, and that's the number that we're just going to take and square in order to get y. Take a value for x, square it in order to get y. When I graph quadratic functions, I often use negative numbers. And I'm not going to focus here in this particular unit on where the vertex is of the parabola, which is the lowermost point, and how I find that, and the max and mins of the functions. We're just going to try to look at graphing quadratics. So I'm always going to put some negative numbers in and some positive numbers in order to see this curved shape, or this curved shape. So when I put a -2 in for x here, and I ask you to square it, a -2 times a -2 is a +4. When I put in a -1 here for x, a -1 times a -1 is a +1. When I put in 0 and square it, 0 times 0 is 0. And now when I go put some positive numbers in, like a 1 in here for x, 1 times 1 is 1. And then finally when I put a 2 in there for x, 2 squared, which is 2 times 2, is 4. And I go to graph these ordered pairs. So the first one is x is a -2, y is a +4. So I go to the left 2 and up 1, 2, 3, 4, and I plot that ordered pair. The next one, x is a -1 and y is a +1. So left 1 and up 1. The vertex is at 0, 0. And then my next ordered pair is to the right 1 and up 1. And I'm starting to see the symmetry of this parabola. The next ordered pair is to the right 2 and up 4. And now I connect the dots from left to right, and so I'm going to, you know what, I actually might go here and sneak in a -3 into this table. So if I took a -3 and squared it, I'd get 9. So if I went to the left 3, I'd go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And I could also come over here and put this dot right opposite it because I'm seeing the symmetry of this parabola. Again, connect the dots from left to right, trying to make this look like a curve. And then don't forget that I could go on. You know, I can put a 3 in here and get 9, and I can put a 4 in here and get 16, and I can put a 5 in here, and 5 squared is 25. You know, so I can keep going and on up and on up and on up and going. So there's no limit on what I can put in. There is, however, a limit on what I can get out. But before we go there, let's just state that the domain of a quadratic function is always, please take note of this, is always all real numbers. There is no reason why you can't put negative numbers in there and square them. We did it. There is no reason you can't put 0 in there and square it. We did it. There's no reason you can't put positive numbers in there and square it. We did it. You can put fractions in. You know, I tend to use integers, but we can put fractions in. We can put any real number in. However, for this particular function, the range of the function is the y values. what y values come out of this function? What possible answers? And would you notice that this is the y-axis, and there are no y values that got used below this point, right here. No y values that got used below this point. And at that point, y is equal to 0. That's the vertex, 0, 0. So the range of this function is all real numbers where my y values have to be greater than or equal to 0, because I see y values way up here. They get down to 0, way up here, and go back. And that's all I would expect. If you let your graphing calculator do the work for this, you'd have, let's see if I can do this pretty quickly. Clear these. So you just arrow down and clear. Doesn't matter if I graph this in y1 or not, but I'm going to go x squared. Let's look at our table, and let's start it at some negative numbers. Let's start at a -4 and have it go in increments of 1. And so let's just look at that table. So I just want you to see that the range can be found also by looking at these numbers in the table. 16, 9, 4, they're going down 1, going down to 0, but then they start going back up again for y. So the range of my function can be seen over here as well, and it looks as though I'm using all kinds of numbers for my domain. And then if I hit the graph key for this one, I can see that parabola show up that we just graphed as well. Let's do one more. Let's graph the one on the far right side, y equals x squared minus 3. So if I were to do this by hand, but remember, it's not necessary for you to do this by hand. I'm going to pick a few of these, and then I'm going to let the calculator do the work for me. So I'm going to put negative numbers in for x and see what values come out for y. So first, when I take a -3 and square it, I get a positive 9. If you put this in your calculator, you've got to put it in parentheses or it will not give you a positive 9. So a -3 squared is a positive 9. 9 take away 3 is 6. If I put a -2 in here and square it, I get 4. 4 take away 3 is 1. If I put a -1 in here and square it, I get 1. 1 minus 3 is a -2. If I put 0 in here and square it, I get 0. 0 take away 3 is a -3. And likewise, this is going to be a -2. It's going to be the same as that. And then this one's going to be 1. It's going to be the same as that, because I have symmetry around the y-axis. And this 6 and this 6. So I'll go to the left 3 and up 6. I'll go to the left 2 and up 1. I'll go to the left 1 and down 2. And then right here, x is 0. Don't go anywhere in this direction, but go down 3. And then on the right side of the y-axis, I'll go to the right 1 and down 2. And then I'll go to the right 2 and up 1. And then I'll go to the right 3 and up 6. And I will draw a curve from left to right of the graph of this parabola. I'll put arrowheads on it because I know that it goes on. And then finally, again, I was able to put any numbers in for x. So the domain of this function is all real numbers. But a quadratic function, its range, is always going to have some limitation. So it's going to be all real numbers, but the y values for this, they're up here. They're in the second quadrant, they're in the first quadrant. They go negative a little bit, but y values only go negative to how much? This y value, how much does it go negative? Oh, just till a -3. So y is greater than or equal to a -3. Look at my table right here. A -3 was the smallest number I got to, then I started going back up again. Domain and range are very, very important when we talk about real applications of functions. We've got to decide what we can put in for x and what we shouldn't put in for x, and then what we can expect as a result out. I'm going to come back and do a few more. You might practice the next two on your own, and I'll do those a little bit more quickly.